All right, so just a reminder of what we did last class. Oh, let me just this big. There you go. Just a reminder of what we did last class. So I just stated that if f of x is equal to the ln of x, then the derivative was equal to 1 over x. Okay, so this we proved yesterday. It was not an easy proof, but we did it. Okay. Second thing I want to prove now is that if f of x is log in base a of x, then f prime of x will be 1 over x times ln of a. Okay, so this is what I prove now. And then we're going to prove after that if f of x is equal to e power x, then f prime of x is just e power x. And the last thing is that if f of x is any number power x, then the derivative will be a power x times ln of x. Okay, so this is what we're going to prove. So this is done. So let's prove these ones now. Okay, so let's go. Proof that if f of x is equal to the log in base a of x, then f prime of x is 1 over x times the ln of it. Okay, so let's prove this. Okay, so since we worked so hard yesterday to prove that ln of x is 1 over x, so now we're going to take advantage of the hard work that we did, and I'm going to use it here. Okay, so first of all, f of x is the log in base a of x, means that it's equal to, I can write it as ln of x over the ln of a. Do you agree with this? Okay, it's the fourth rule of logs, is that if you have two logs, you divide two logs that have the same base. In this case here, the base is e, then a becomes the base and of x, right? We explained this, and you've seen this in high school. We didn't prove it though, and we could, but not right now. Okay, so now if I want to derive this, so f prime of x will be the derivative of this. Okay, I'm going to keep with my pink notation for derivatives, prime. Okay, and that is equal to, so ln a is a constant, so I can pull it out, right? I can pull it out. So it's 1 over ln a times the derivative of the function. Good. And ln x, we just showed yesterday that this is 1 over x. So this is 1 over ln a times 1 over x, and that's our proof. It's done. Okay, that was an easy, very easy proof once we prove that ln of x derivative is 1 over x.
If we have something like this in the exam, we have to prove first that ln of x is equal 1 over x, right?
No. Now you could use, now that we proved it, you could always use that the derivative of ln x is 1 over x. I'm not going to ask you to prove the product rule every time you use the product rule, you know. So same thing. Every time I'm asking you for the derivative of sine, you know it's cosine. You don't have to prove it. We're using definition. Okay. So same here. We're going to use this. You have to know. Okay. So these rules, you have these rules up here. Okay. You have to know them. Okay. By heart. Okay. So but we proved them. Okay. So this is done now. Let's show that the derivative of e power x, okay, is equal to e power x. Okay, so again, so let me, can I change, can I turn page? Yes. So proof that if f of x is equal to e power x, then f prime of x is again e power x. Okay, that's what I want to prove. Okay, so let's go. So ln, this is how I'm going to start. Ln of e power x is equal to what? What's ln of e power x?
X.
X, right? Ln of e power x is x. Why? Because e power what gives me e power x? Well, x. E power x equals e power x. Okay, so this is something that's true. So, therefore, I could derive both sides, and it's still going to be true. So the ln of e power x prime has to equal to x prime. Any questions so far? Okay, now let's derive the rest of the left side. How do we find the derivative of this? Derivative of ln is 1 over e to the x times the derivative of the inside. True? Chain rule, right? And that's equal to derivative of x, which is 1. And then I'm going to send the e power x up here. And so I'm going to get e to the x prime equals to e power x times 1, e to the x. And that's it, I proved it, that the derivative of e power x is e power x. Any questions? Okay, let's.
Excuse me, how did you turn the 1 over e to the x to just e to the x?
1 over.
The fraction just above that, how did you turn that into e to the x?
Oh, from here to here?
Yeah.
I just multiply both sides of the equation by e to the x.
Oh, okay. Yeah, it makes sense. Thank you.
Okay. So let's go back to my paper here, and I like to put check marks everywhere, so this is proven done. Okay. So now I want to prove that if f of x is equal to a power x, then the derivative will be, so a to the x times ln of a. Okay, so I'm going to start by noticing that ln of a power x is equal to, so if I bring the x in front, x ln of a. So I'm going to derive both sides. Okay, and if I derive ln, as you know, this is 1 over what's inside times the derivative of the inside, right? The usual chain rule. equals, and x times ln a, the derivative. Ln a is a constant. So it's just ln a times the derivative of x, which is 1. And so a to the x prime is equal to, if you send the a to the x up here, a to the x times ln a, and I'm done. That's what I needed to show.
How do you know that ln of a is a constant?
Because a is a number here. A is a number. X is the variable. The function depends on x only, not on a. If a was a variable, I would have said f of ax. It would be a function of 2 variables, or f of a, which would mean that a is my variable. Okay? So I'm saying f of x, it means that the function depends on x, so x is my independent variable here. Good?
Okay.
That's it. It's proven. So 2 seconds. I could just, this is done. Okay? If f of x is a power x, f prime is a to the x ln a. Okay? At this point, we just need to do a lot of examples. Okay? So let's practice this. All right, so example. Find f prime of x. First of all, let's say f of x is 5 to the power of cos x. Second, f of x is log in base 2 of, let's say, secant cubed x. Three f of x equals e power x cubed plus 5 divided by cos of x. Okay, so try these 3. So f prime will be, so the derivative of a power something stays, so 5 power cos x stays, times ln of 5, as usual, times the derivative of the exponent, the usual chain rule. And the rest is straightforward, so 5 to the power of cos x times ln 5 times negative sin x. Questions? Okay. Okay, next one. F prime, so log in base 2 is always 1 over what's inside, so secant cubed x times ln of 2 times the derivative of the inside, so the derivative of secant cubed x. Okay, so what you could have done here is you could have pulled out a power 3 in front before deriving. That would have been smarter. Okay, put the 3 in front because it's power 3, so 3 could go in front and then you derive. You would save some time, but it's okay. So equals 1 over secant cubed x ln 2 times the derivative of secant cubed is 3 times secant squared times the derivative of secant. Okay, And then equal, last step I want to do here, 1 over secant cubed x ln 2, 3 secant squared x times derivative of secant is secant x times tangent x. Okay, so as you see, all the secants will disappear. Secant cubed over secant cubed disappears. Okay, so in this case, it's practical to simplify. So it's going to be 3 tangent x over the ln of 2. Any questions?
Yeah, actually, in an exam, would we be expected to simplify that?
I'm going to ask you to simplify. Yeah.
Okay,
If
thanks.
there's simplification, I'm going to ask you to do it. Okay. Or else I'm going to specify do not simplify your answer. Okay. So it'll be clear. As you see probably in my old test, you could probably see that sometimes I say simplify, sometimes I don't. Okay. This one here. So of course there is a division, so we have to do the quotient rule. So it's e power x cubed plus 5. So the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. All right, so 2 little derivatives to find. So e power x3 is just e power x3 times the derivative of x3. The 5, of course, disappears. Times cos x minus e to the x cubed plus 5 times negative sine x. And the bottom, I'm not touching. That's it. The only thing left now is this little derivative to evaluate. So e to the x cubed times this is 3x2 cos x minus e to the x cubed plus 5 times negative sine x and over the cosine of x squared, and I'm done. Any questions?
Is that all for number 3?
Yes?
Okay.
What is it? What did you say? I'm sorry. Is what?
Is that all?
Yeah, that's it.
Okay.
That's it. Okay. So let's go to let me think if we do implicit differentiation now. Okay, so I'm going to post some practice for this. Okay, you should be fine now. So we're almost done all of derivatives. Okay, we're almost ready to start applications. Okay, so at this point, I'm just I'm telling you what's left. It's just implicit differentiation, logarithmic differentiation, and that's it. After that, we could start doing some much harder examples. Okay, so I'm going to give you challenging derivatives to find, and then we'll move on to the last part of the course. Okay, so implicit differentiation. Okay, so here you have to be a bit careful. So here's an example of an equation that's written explicitly, an equation that's written implicitly, okay? So, or a function. So we have, let's say, y equals 5x3 plus 2x minus 1. This is a function. Y is written explicitly in terms of x, okay? So this is y is expressed explicitly. Okay, well here, if I'm telling you x, y, 3 minus 2y plus 5x equals 92. Well here, of course, there's a relation between x and y in this equation, but now you see that the y and the x are mixed together. And so y is expressed, oops, y is expressed implicitly. Okay, so explicit, implicit. Basically, explicit is if the y is isolated, implicitly if the y is not isolated. Okay, that's if you want to keep it simple. Now, if, of course, I'm interested in, so we treat y as a function of x, okay, which means that y is equal to y of x. Okay, y is a function of x. Okay, so here I see it, y of x equals this. But here, if I want to express y of x, I can't. I mean, I can't isolate y here. It's a third degree polynomial with the variables inside. And if this wasn't y7, for example, then I would really be stuck. Okay. So how would we find the derivative? How would we find y prime here? That's easy. And how would we find y prime here? That's not that easy. Okay, so let's try to find y prime implicitly. Okay, that's what I'm called implicit differentiation when we get situations like this. Okay, so look at how this works. Find y prime. Okay, so don't forget, very, very important is that every time you see y, you have to understand that y is a function of x. Okay, so y is an expression that has x's inside. Okay, so I'm going to do the first one. So let's say x2 plus y3 equals 2x minus 1. Okay, that's a very basic. Okay, just to start. So I'm going to do the derivative of both sides. Okay, so the derivative of x2 is, of course, 2x plus the derivative of y3 is what? What's the derivative of y3?
3y2.
3y2 times, don't forget the chain rule, right? Because y is a function of x. Don't forget, I'm just going to go back here a bit. Okay, so y is a function of x, so I have to do also y prime. Okay, times y prime, don't forget. Because y of x, y could be sine x, for example. Y could be ln x. So I have to do ln x. If y is ln x, I have to do ln x prime. Y is sine x, I have to sine x prime. Okay, whatever's inside, whatever I put to the power of 2, I have to derive. Equals, and here this is of course 2, and the minus 1 disappears. Is okay? You get it? And now I could isolate y prime, and I'll be done. Okay, so 3y2 times y prime is equal to 2 minus 2x, and therefore y prime is 2 minus 2x over 3y2. This is my derivative. Okay, so yeah, the derivative depends on y also. Okay, that's not a problem. Okay, so now this is a curve. Imagine this is a curve in space, sorry, a curve in R2 plane, and you want to find the derivative at every point. So let's say point 0, -1, right? Point 0, -1 is on this curve. If you plug in x is 0 and y is -1, it works. So point 0, -1 is a curve here, is a point on this curve. Well, what is the slope of the tangent? Well, you plug in x is 0 and y is -1, and you're going to get 2/3. That's going to give you the slope. Okay? Questions?
Yeah,
Can you
sir.
repeat how
Oh,
do we get the
Yeah.
slope?
Yes, I'm listening.
Can you repeat how to get the slope? I didn't really get it.
How to get the slope? We're going to do an example with finding the slope in a minute.
Okay, perfect.
So just for now, I just want you to be able to find the derivative. Okay, so let's do question 2. Okay, so I'm going to leave this in front of you so you could base yourself on it. So let's say 3y4 minus 2x3 plus y equals to 8. Okay, so let's find y prime here. Okay, so the first thing I'm going to do is I'm going to find the derivative on both sides. Okay, so the derivative of this is what? 12y cubed times y prime. Okay, minus 6x2 plus the derivative of y is just y prime equals to 0. Questions? Okay. So I'm going to send the 6x2 on the right, and I'm going to factor out a y prime on the left. So y prime times 12y3 plus 1 equals to 6x squared. And so y prime is 6x2 over 12y3 plus 1. This is my derivative. This gives me the slope at every point xy on this curve.
Can you repeat, please?
Sure. Did you understand the first step on finding the derivative or not?
Yeah.
That? This is
Yeah.
okay?
Yeah.
Okay, so after from here to here, what I did is I sent the minus 6x2 on the right to become plus 6x2. Okay, and then on the left side, I pulled out a y prime. I factored out a y prime. You see? See? Y prime times 12y3 is 12y3y prime, and y prime times 1 is y prime.
Okay.
And then I just divided 6x2 by that to get y prime.
Okay.
Okay? Let's do one more, because I have a little space here. Number 3. So 2y minus 3y2 plus x equals to y cubed. So I derive the left side, 2y prime minus 6y y prime plus 1 equals 3y2 y prime. Okay, so it's very easy to forget this y prime. A lot of people forget it. I always notice, and this y prime, people forget it. Okay, so let's send everything to the right. So 3y2 y prime plus 6y y prime minus 2y prime equals, I'm left with just 1 on the left. Factor out y prime, so I get 3y2 plus 6y minus 2 equals 1, and so y prime is 1 over 3y2 plus 6y minus 2.
I have a question. Why does 2y doesn't become like 2? Because when it's 2x, it just becomes 2, right?
2y
Yeah,
is here. How does it become 2y prime?
yeah.
Okay, because if you derive 2x, it's
Mm-hmm.
actually 2 times the derivative of x, which is 1. That's why it's 2.
Mm-hmm.
But now it's 2 times y. Now y is not like x, because y is a function of x. So you have to do y prime.
Okay.
Good? Okay. Can we complicate things a bit? Let's complicate a bit.
Come back to the last page, like 2 seconds.
Sure. Okay, continue.
Yes, thank you.
Okay. So let's complicate things a bit. So you have to be careful now. So still find y prime. So x plus x y cubed minus y equals 3. Okay, so let's derive everything. This is 1 plus, and now here, what's going on here? So here we have a multiplication. You see, x times y cubed, that's a multiplication between two functions. So I need to do the product rule here. Okay, so the derivative of x, which is 1 times y prime, or y cubed, sorry, plus x times the derivative of y cubed, which is 3y2y prime. Okay, so have to be very careful here, careful. There is a multiplication, so there is here a product rule. Okay, be very careful. The rest is easy. So this minus y prime is equal to 3. Sorry, to 0. The derivative of 3 is 0. Good. And now at this point, it's just algebra. The idea is to factor out the y prime, and that's it. So let's just rearrange 1 plus y cubed plus 3xy 2y prime minus y prime equals to 0. So everything that doesn't have a y prime, I'm going to send to the right side. And these two here, I'll factor out a y prime. Y prime times 3xy2 minus 1 equals to negative 1 minus x cubed. And so y prime is negative 1 minus y cubed over 3xy2 minus 1. Question? Okay. It always looks easy when I do it, but when you're going to try it, you're going to see that you're going to start asking yourself questions. So let's try one. x3 minus x2y2 plus xy equals to e power x. Let's go. So the derivative of the left side will be 3x2 minus, and here I have a product rule. Okay, careful. So it's 2x y2 plus x2 times what? 2y. Is that okay?
No, multiply by y.
Oh,
y
thank you. Avoiding it. Okay, very good. Okay, I left a little space. I wanted you to react. Plus, and here I will have again a product rule here. So it's 1 times y plus x times y prime equals e to the x stays e to the x. We know that. All right, now it's just algebra. So this, if you do this on the test, if I ask you to find the implicit differentiation y prime, and you do this, you already get about half your marks because you did the derivative. At this point, it's just to isolate y prime, and that's just algebra. Okay, it's important, but you still get a lot of points because I just want to make sure that you know how to find the derivative. Okay, so let's do it. First thing, I'm going to get rid of the brackets. I want to go slowly. So 3x2 minus 2xy2 minus 2xy prime plus y plus xy prime equals e power x. Okay, so I see two y primes here, one here and one here. Okay, everything else goes on the right. So on the left, I have y prime times x minus 2xy equals, and on the right side, I'm going to send everything else. So e to the x, so minus 3x2 plus 2xy2 and minus y.
On the third line,
Here?
on the third.
Here?
Yeah, here. Why is it minus 2xy?
This?
Yeah.
Oh, it's x2, sorry.
Okay.
Thank you. Yeah, you're right. I forgot the 2 here. Perfect, thanks. Okay. And so y prime is e to the x minus 3x2 plus 2x2y2 minus y. So you see how easy it is to make a mistake. Okay, I've been doing this for years and years and years, and still I forgot a little 2 here, right? It slips, the state slip. Okay, so you have to be very careful and go very slowly. And that's it, that's my answer. Can we increase the level of difficulty a bit? You guys could handle this?
Yeah.
Okay. So let's go number 6. Let's see. E to the power of y minus the cosine of xy minus xy4 equals to 5x plus tangent x. Okay, so the relations are becoming more and more complex. So the idea is to isolate y prime. Right? Let's see how we do this. Sorry, I'm just re-recording because I forgot to record. At least you will have it when you see the video. You could pause it and look at all the steps. Sorry, what was your question?
Yeah, on the second last line, you factored out y prime.
Yeah.
But then why is it x sine of xy?
This?
Yeah.
It's from here.
Okay.
Pull out y prime, x sine of xy.
Okay, and what about y sine of xy?
What about what?
Y sine of xy. There's nothing to factor there?
No, there's no y prime here. So I sent it on the other side. Here he is.
Oh, okay, okay.
Okay.